all about solving trig equations. And we start basic. Some of these you already know. Okay, so I got to tell you. Do you know what an identity is? It's yeah, kind of. An identity in mathematics is an equation that no. This is okay. So an identity, kind of in English terms, right, is an equation that works for all real numbers. Okay. That's what we're going to get to. So if I throw something up there like this, and I'm going to put it in terms of trig because that's what we're studying here. Sin x plus cosine x equals 1. Okay. If that's an identity, any value of x I plug in will give me 1. Okay. Or it can be or it's not an identity, and I could find an x where this does not equal 1. Right? So an identity would be works for all x. Okay. Or not an identity means it works or does not work. For one or more x values. Okay. So this example here. Okay, is it possible for us to show that this works for all x values by testing it with every x value ever known? No.
That would take forever.
Even I would be miserable. Okay. So the best way to approach it, the question, is it an identity, is to try to show that it's not by finding one x value that does not work. Okay? So if we're thinking unit circle, we just want unit circle, right? Give me a value off the unit circle. Okay. Since we're in the real numbers, we'll do radians. Okay. So I've picked a real number. Remember, radians are a real number. What is the sign at pi over 6?
Or no, 3 over 2.
Which one is it?
1/2. 3 over 2. 1/2. It's 1/2. 1/2.
The sign is 1/2. The cosine is root 3 over 2.
That's a neat.
Question marking this. Is that true?
Why would you write it down and then question mark? Why would you question mark it as you wrote it down? Now I might have to erase something.
You don't have to erase something, just add a question mark. Okay, so this actually comes out that 1 plus root 3 over 2 does not equal 1, correct? Okay, so is this an identity? Does this work? No, so it is not an identity. Okay, you're gonna be asked to look at these and say, is it an identity or is it not? Okay. If you can produce what this is called a counterexample. If you can produce a counterexample that shows this is not an identity, you're good. Okay. The questions are usually phrased, find a counterexample. At your level, find a counterexample to show this is not an identity. Would probably be the question you're going to answer. Okay, so use the unit circle, quadrant 1, and test. Okay? So this gives you some more unit circle practice. Right? Not an identity. Good? Good. Okay, so let's talk about some of the identities that you... Okay, you're fine. I can occupy myself. Here's an identity you probably know. Secant, right, is what? 1 over... That's an identity. So you already know some identities that you can use. Okay, what about cosecant? 1 over sine. Okay. Cotangent over tangent. Yeah, so those you've already seen before, right? You will use these very heavily. Okay. One of the ways to deal with solving trig equations is to change it into sine and cosine. Conversely, we can write cosine as what? Cosecant, yeah. 1 over. It's on the board. Secant. You see 1 over secant, you can write it as cosine. Right? But these are just manipulations of this, correct? I mean, it's the same thing, just algebraically changed. So what about sine? Guesses? 1 over cosecant. And tangent is... There you go. Okay, so you have some options. I'll show you how to use these. Right now it's basically just information. Okay.
What is under the sine?
Sine theta, 1 over cosecant. See, cosecant's 1 over sine. So you have the
I just couldn't tell.
inverses. Okay. So basic trig identities there. The next ones we're going to actually build from the unit circle. Okay, so okay. Wait for it. Oh, that was anti.
Wait, so those are all identities?
Yes, these are all identities.
Okay.
So any Any value you plug in here, it could be 25, it could be pi over 8. Anything you plug in, it works. There's no number that doesn't work for it. Okay? Unless there's a 0 in the bottom. Okay. We're not worried about that. Okay, let's talk about the unit circle. Right? This here is, the coordinates are cosine and sine, correct? Okay, so you agree there. We know that now. It's also xy, right? With x, y. Right? So the x is cosine theta, the y is sine theta. You agree, hopefully, as we get over that. Okay, this is 1. This is a right triangle. What theorem do we usually use to solve right triangles? Pythagorean theorem, right? Okay, so x squared plus y squared equals 1 squared, right? Can you create a sine and cosine identity from that? What is it?
Do we have to put the theta there?
Yeah. That's an identity based on your knowledge of the unit circle, right? Okay, so not really building anything new, we're just going a little deeper with what you know, right? That's probably one of the most important identities you can know. Yeah, it is. We use it a ton. I'll show you how to apply these here in the next couple weeks. So right now it's just information. Can I rewrite that to something of this nature? Algebraically manipulated. Cosine squared theta equals 1 minus sine squared. Right, I just subtract this over. So I would advise you, all you have to remember is the top one, and you can generate
Ted,
these
can you
last
do that the other way around too? Right?
Say that.
You can do that the other way around too? Yeah. Or yeah.
This is
like
what
that.
you mean?
Yeah.
Yeah, that works too. Because all three of those are identities. Again, these are built from the original, so whether or not you want to remember those doesn't matter. Okay, so we can use similar methods for this. Yeah, that's right. Secant squared is 1 plus tangent squared. Another identity, and then we can do cosecant and 1 plus cotangent as well. There. You can manipulate this first one to build these. Okay. They're just bullet points, so you don't think they're negatives. So if you're curious how these are built, cosine is 1 over cosecant, right? Sine is 1 over secant. You can manipulate things by using fraction math and algebra, okay, to get these two. If I want to add, let's see, this is 1 over cosecant, and 1 over secant and 1 over cosecant, right? If I want to add those fractions, I need a common denominator. So I have to create a common denominator. In that process, you're going to come out with tangent and cotangent. Okay. The different ways to manipulate it. Again, that's not today. I will teach you that later. But right now we're just focused on what is an identity. Okay. One more from the unit circle. If I want to calculate tangent, that's the y over the x, correct? For the unit circle. If I asked you tangent pi over 4, you'd put the y over the x. I see one head nod.
Yes.
I hope. Okay. Now can I put this in terms of sine and cosine? What's the y value? Sine and cosine. So I can write tangent in terms of sine and cosine. I can also write cotangent. Yeah, it's the reciprocal. So it's 1 over sine over cosine, but the resulting fraction mathematics gives us cosine and sine. All right, so that's just information, most of it. And can you find a counterexample, right? Questions? Good. You guys are so thrilled. Okay, I have one more thing to show you. Oh, if. Whoops. Okay, if that is true, calculate cosine theta. Yeah, this is 1 over cosine, right? Yeah, so cosine theta would be the reciprocal, so
Those problems aren't that easy.
some of them are that easy, yes. You're using your identities, it's very straightforward, right? So this tells us 1 over cosine is 3 over 2, which then implies that we can reciprocate. So there's one way. If it's that straightforward, bueno, right? Very good. Okay. Now let's see if cosecant 4 over 3 by tangent. Is that one so straightforward?
No.
How?
No.
I will. Possible.
Well, I'm not one.
It's okay.
I can write that.
Sorry, no.
Okay, there are a couple ways. So, Hunter, what's your idea?
Do it like we did with the last one. Sine is.
Okay, so 1 over sine is 4 over 3, which means that sine is 3 over 4. Okay. Is 3/4 on the unit circle? No, it's not.
No, but it can make a triangle.
Oh.
A triangle, 3, 4, 5 triangles, meaning that n would be 5 over 4.
So you're telling me,
that.
and what? You got, I think.
Xavier, where did that come from? Like, when did you sporadically become smart?
So, the other way to tackle these is to remember SOHCAHTOA, right? Sine is opposite over hypotenuse, correct?
Yeah.
Right, so the 3 is the opposite, hypotenuse is 4. It's not a 3, 4, 5, sorry.
Well, when you divide that by
What is this value?
Sine theta over
It's Pythagorean theorem,
Oh, okay.
right? So this x value,
I was thinking the same thing.
square root of 7.
No.
right?
Well, yes, and
So x squared is
yes,
7?
you remember.
Yeah, 7.
And x is root 7, right? So now calculate the tangent is what? No. TOA,
3 over root 7.
opposite over adjacent is 3 over root 7. Do we like roots in the bottom?
Yes.
No, because they're ugly,
Yeah.
just like some of you. Okay.
Yeah.
So we multiply by, I was talking to the boys.
Accept it. I was like, yeah.
Okay.
No bullying, think. I didn't
Yeah.
think first.
Yeah.
Call me ugly, I don't care.
Should they do that?
That was targeted at the boys. And you have your value for tangent. Okay, so hopefully you get this kind, but if you don't, you have already done the math to find this value. You just got to bring it into your brains, okay? Are we good?
Wait, just wait.
No, okay, I know it's Thursday and you're really tired, aren't you?
Oh,
Guess what?
yes.
So am I. Get over it. Okay. We're still here, we still have to work. That's it for today. I'll give you your homework and we'll be good. Okay. So,
Is that a 0 over h?
What?
opposite over hypotenuse.
Oh.
I was like, H is
The off height.
variable. This is like,
I'm splitting this into 2 days.
Oh.
Just to give you some guidance.
So,
Okay, I can't think and do 2 things at once. I apologize. That's just
7-1A is due on Friday.
No.
And,
I wrote my music man project. Please. I told myself, please.
so. This is not none of. It's all due Tuesday. Okay, I'm gonna give you a little break there.
Last night.
Study your unit circle tonight. If you wish to start tonight, this is what we've done today. And that's what you could probably tackle. If you want to start, plus the spiral, obviously.
Yeah.
If you want to leave your weekend more free. This we will tackle tomorrow. Okay. So,
Hi, let's associate that.
Will we get that? That handout?
41%. For it.
I already posted
You
it.
have 41.
Yes, good. When I posted the unit circle handout in Google Classroom, attached to that should be an identities handout.
I'm gonna cry.
Okay, it's got all of them on it. Let me see if I can find it real quick. Don't crash my computer, please. You suck.
It's you.
Okay, we're gonna go back to chapter.
When is this?
I can see the corner of my eye.
Oh, come on. I want you over here. Oh, I'm gonna do that. Sometimes the external does
Oh, I don't know.
Talk about not fully.
I didn't use my words. I'm sorry.
This is attached to Google Classroom. All of the identities. Again, each one of the boxes has its own day, so don't get all wrapped up.
I'm shooting this so bad.
I'll move it up to the top so you can have access.
I'm shooting this marker so bad.
Do it.
Do it.